my own son yesterday. He's in intro. He's taking intro right now, intro to applied and pre-cal. He's like, do you have any homework? No, no homework. I'm like, let me see what you've got, right? And I'm like, well, explain this to me. Oh, I don't know. I don't know how to do it. It's like, oh, yeah, you need to do some homework, okay? And so that helped, actually. He was able to get it after all, so. Sucks to have a teacher as your dad, right? Can't get away by saying we did nothing. Anyways, here we go. Calculate the total exposed surface area and total volume. Surface area. Oh, you're coming. Page 50. All right. So surface area, folks, I'm going to say this. You want to find all the surfaces that if you were to spray paint that shape, right, would need spray paint. That's basically what you're thinking of. So let's do the surface area first. And I know some of you did this already, so just follow along, make little notes. If you did it differently, that's fine. But if I were to talk about the total surface area, okay, I would think this way. I would find the surface area of the entire cylinder, okay? I would consider this a closed cylinder at first. And then I'm going to see what do I need to take away, and then I'm going to see what do I need to add, okay? So what should I take away here? This circle, right, the smaller inner circle, there are two, one in the back and one in the front, right? This top one and the bottom one, that needs to be subtracted, okay? So I'm going to go 2 minus 2 small circles. They basically make that whole. And then I'm going to add the actual like inner lining that was created by that circular hole. So almost imagine somebody drilled a hole through this cylinder. So that inside tube needs to happen. So I'm going to call that plus lateral surface area of small cone or something like that. I think it's very good for us to first tell us what is it that we're going to do before you do formulas. Okay. All right, let's start. Surface area of the large cylinder. I didn't put large, but I do use small, so it's good enough. Mr. Dirksen, do I need this for my test? No. But I would like to see formulas at the very least, okay? Formulas are a must. All right, so here you go. Surface area of the large cylinder. Let's find some information here. If the diameter, outside diameter is 25, then my capital R is 12.5. Okay. Lowercase r, how about what is the small diameter here? I gotta go 25 minus 2, right? So this is 21. Right? And half of 21 is 10.5. So lowercase r is 10.5. Okay, so we've got that figured out. The height in this case is the same for the small cylinder inside and the large because it goes right through. Okay, the hole goes right through. There's no bottom to it. So a couple of observations. So here we go. Surface area of the cylinder. I'm going to go 2 pi r squared, right, plus 2 pi RH. Does that make sense? But Mr. Dirksen, there's something missing. Yes. At first, I treat it like a closed cylinder. And then, so you can do square brackets if you want to partition it. So this is that part. Minus 2 small circles, so that'd be minus 2 pi radius squared. So I'm taking away the top circle and the bottom circle because that's not going to get painted. It's not there. Okay, that surface is not there. Plus lateral surface area of the small. Nobody stopped me here? You're just laughing inside. It's like, yeah. There, cylinder. So how are we going to do that? It's just lateral surface area, right? You just want the sides of that. So we got to go 2 pi lowercase r h. I don't know why I use capital H, to be honest. It doesn't really matter. So I'm just going to stick with capital H because it's the same. So I'm going to go over here and just say that's where H is from. Okay. So in a sense, if you want to partition this, square brackets are great ways of saying, okay, this part, and that part is taken care of. Okay. I know my key is probably has done it differently. I know that. But maybe that's exactly what I'm trying to show you, that there are various ways to get the answer. It's not just one way. So if you copy my answer, I would still say, hey, that's part of learning, but not necessarily the only way of doing it. Okay, so here we go. Did I make a mistake, guys, and you're just not telling me? Everything is good so far? Don't be so serious, guys. Life is good. I know this is scary stuff, but we're trying to have fun too, right? So 12.5 squared plus. So it's going to go a little faster because I'm just plugging in. H is 64.5. So I got that part. If you want to keep the square brackets, not a problem at all. Minus 2 pi r squared. Now I'm looking at the small one there. Let me move that up. And that can also get a square bracket for now, plus 2 pi rh, so it's 2 pi lowercase, so that's 10.5 times 64.5. There we go. And the bad thing about going off of this script is that I have to redo the calculator part. Okay, so 2 pi times 12.5 squared plus 2 pi times 12.5 times 64.5. So that's 6,047.5658. Do not round, okay? So that's this part. Okay? Minus this part right here, 2 pi times 10.5 squared. Okay, so that's 692.72 something, plus that last part, and so the reason I'm doing this is to make sure I walk you through and you have the steps, right? Like what reasoning went behind it, right? So now that I have everything calculated, it's basically just copy paste, right? So go up, copy that, minus 692 plus 425, and it's the same answer. Yes. I was worried about it, honestly. I was worried for a bit that I was gonna, maybe I typed it in wrong. 9610.13 squared centimeters, right? Usually on a big question like this, I won't do that to you, but please watch your units. Like for example, up here, if all of a sudden you got meters and centimeters going on, watch it, okay? Because the province is somewhat notorious for doing that. So that's our surface area, okay? So that's that. Next we have the total volume. Volume, in my opinion, is a lot easier. You're not worrying about faces missing. You just want volume of large minus volume of small if there's a hole. If things are stacked, you want to add them, right? You want to add the volumes of those shapes. That's it. Okay, so you don't worry about is there a face missing, what is happening. So I'm just going to go volume of large cylinder minus volume of small cylinder. Okay, that's all that is to it. And that one is pi r squared h minus pi small radius, right, squared h. They have the same height, by the way. And I'm just going to show you, I'm just going to copy it right now from my notes here. That way you at least have it, right? And if you, so this part right here gives you 3166136 dot 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 minus 2234025, and your final answer is 9,321 and 11. That's cubic centimeters. Okay, so 9321.11 cubic centimeters. So if you wanted to know how much concrete you need to make this, how much plastic to make this pipe or something like that, that's what you would be looking for in that case, okay? All right, moving on. Do you need me to go over this one? Do you need me to go over it? Or are you all... I think the only... this is basically the same idea as the previous one. The only thing is you've got this triangle that you need to find the height for. Because there's two triangles, one at the bottom, one at the top. And there are three sides around it. Like that's the whole, like the big shape. And you would go minus 2 squares, right? Plus the 4 rectangular pieces that make the sides of this hole. Okay, so I think the key is, I'm just going to show you the key. If you haven't, I'm just going to focus on the surface area here. So I highlighted the height. I found the height of the triangle, right? I had to split the base in half. Height is a leg, right? So you find it by using Pythagorean theorem. So basically how it goes is surface area of triangular prism would be 2 triangles and 3 rectangles, right? This is, I'm going to modify the key here a little bit. This is in a sense like that prism, that large shape. You're going to go minus 2 squares plus 4 rectangles, right? Those are the rectangles on the side. And then you just paste and go. If you need help with this, come and see me at lunch or something, right? Or before class. I'm going to gladly walk over it, but we only have this much time. I can't do every single question with you guys, okay? So I'll keep going. But I have no issues walking through it with you, right? Or even if you just want to work in class and see and just confirm as I go. Okay, let's do this one. This one has partial or composite shapes, right? So we have halves, quarters, things like that. So we'll do the surface area, but it says omit the bottom. So in this case, just to make it a little simpler, we would not include the bottom here. We'd just consider that shape sliced in half. All right, so let's do this. Total surface area first, because to be honest, surface area is the harder piece to do. I wish I would have given you the whole shape before slicing it in half. I wish I would have done that. Maybe next year, so if you want to come back. But I'm just going to tell you, I'm going to consider this whole thing almost as if, right, this whole thing just continued, okay? Like there's a bottom piece to it, so I'm just going to say, if I treat it as the whole unit, I'm just going to say at the very end, I'm going to go half of whatever I'm about to calculate. Okay, that's my goal here. So I'm going to leave the half for the very end. So what will I do here? I will find the surface area of a hemisphere. Because this is, right, this will be half a sphere attached to this end. Plus, the middle part is a cylinder, right? But I don't want the circle here, nor do I want that circle here, because it's not exposed. So it's just lateral surface area of that cylinder. Okay? Plus, There's this cone at this end here. I do not want the circular base of that cone, so I'm also just going to say LSA of cone. Now I can write cone, right? Got my shapes right? So this is what you want. You do not care about any of the circles, so we don't have to subtract, but we definitely also don't want to add, okay? Got it? Look alive, people. I did this at home, so why are you doing this again, right? I would still say that's great. Keep doing that. And just watch for little things that I mentioned on the side. Okay, so let's do the hemisphere. That is 2 pi r squared, correct? LSA of cylinder, it's 2 pi r h plus pi r s. Okay? And don't forget the square brackets, because whatever we are going to do, we're going to slice it in half at the very end. That is my suggestion. You can do whatever you want. Okay? If you want to half it right away, my warning would be is sometimes students half the first and the last thing and they forget to half the middle, right? Like, and then you're in trouble, right? It's not going to add up. So let's plug in here. 2 pi, what's my radius here? It's consistently 5 yards, right? Radius is, because they're all connected and they're perfectly connected. They're not like off-centered. So my radius is 5, okay? I make note of that. So this is 5 squared plus 2 pi. 5 is the radius as well for this cylinder, and the height would be, in this case, the length of it here. And everything is in yards, okay? Plus pi r, do I know S? Oh, you can't see that, sorry. I still have to learn how to work this screen, because this screen goes very low here, so I gotta make sure I move it every once in a while. We do have the slant. The slant is 8, right? So we don't need to use Pythagorean theorem in this case, and square bracket that. So keep the half there, and so 2 pi r squared. I'm just making sure I got this, yeah. So this part is 157.079 something. This part is 376.991. The last part is 125.66 something. Okay, we're getting there. We're landing the plane, okay? If I type all of this into my calculator, you get 659.734 something. And now I'm going to half it. So you can actually go right next to it because I need the space for the volume yet. Half of that would be 329.87, and we are in yards, so squared yards, or yards squared. And there you have it. Okay. Does that make sense, Vince? Vince asked specifically, so thank you. Volume. I'm still going to do the half thing, okay? But I'm going to go volume of hemi plus volume of cylinder plus volume of cone. I don't need to worry about faces, right? Half. Move it, Mr. Dirksen, move it up. All right. Hemisphere is, what's the volume of a hemisphere? 2 pi r cubed, and don't forget about the 3 here. Okay? That's a hemisphere. Plus pi r squared h plus pi r squared h divided by 3. So get your formulas right, have that on your study sheets. Let's plug in. 2 pi 5 cubed divided by 3 plus pi r squared. H is 12. It's like that, and then pi r squared. What's h for the cone? I need to figure it out. Okay, the height of the cone is unknown to us. We knew the slant, we need to find the height. I'm going to go up next to the shape somewhere to find a little bit of space there, and then I'm going to bring it back and insert it. Okay, so make sure to write this down. I'm going to go back up and then I'll bring it back down. Okay, so it's probably a good idea to take this, and I'm just going to write it like that, the slant. Okay, so this slant is 8. Okay, this part right here is the radius of the whole thing, this part. So it's 5. Don't be going 5 divided by 2, okay? You already know what the radius is, so it's just 5. So I'm going to find the height there. The height is one of my legs, right? So it's the square root then of the hypotenuse squared minus one of the legs squared. If you do this, you get square root of 39. You can leave it as square root of 39, but I'm going to figure out what the square root is. So second, do you remember how to do that? I hope so. 6.244 something. Yards. Let's highlight that one. Leave it on your calculator. If you want to box this in, that's probably a good idea. Okay, so you can kind of tell that this is an aside. 6.244. So another thing about my videos, if I'm a little too fast at times, you can go back and just make sure you got it right. So let's bring this height down to our volume calculation. 6.244, like that. And now we're gonna, if you type this in, you get 261.79, and that keeps going. Plus this middle part gives you 940. Make sure you get this right, Mr. Dirksen. 942.47 something. Plus this last part, maybe I'll show you how I enter it, because you need to copy paste, right? So pi times 5x2 to square that, times, I'm going to bring down that height. I'm going to hit enter at that point and then divide it by 3. Okay, so that's 163.49 something. Everything surrounded by square brackets. And I know it's tight here, but we're going to make it work. Half of, if I add all of this up, I get 1,367.744, and that keeps going. Hope you can see that. And so last but not least, take this and divide it by 2. So here we go. 683.89 cubic yards. This is my final answer here. That's the final volume of this. Lots of work, I know. That's why I would have suggested you try it at home before you just copy this down. Okay. you might have to, so consider all the formulas for surface area, consider the shapes we've done, consider backwards operations. So when you're given a surface area, you might have to go back, all of those things. So I'm going to ask you to do the first one and the second one. Okay, just give it a try. Give it an honest try on page 24. Okay, and if you need to work with your neighbor, as long as it's not too loud, you may do so. Okay, all right. And just make sure you pay attention, okay? And unfortunately, especially when it comes to this unit, folks, listen carefully. For some of us, this is natural. It just, we just know, like we know when we read. And for others, this is something that you're going to have to just practice and develop skills for, okay? And the frustrating part for me is there is no, the province has never told us, okay, these are all the things that they need to know. They've just like thrown questions at us that involve measurement. And so the skills that I'm trying to get you to practice are just like, okay, try to think when you see chocolate in a container, what are you thinking? Surface area or volume? Volume. It's like concrete in a container. You're thinking volume, right? If you're using cardboard to make a box, cardboard doesn't fill, right? It's just like the outside, that surface area, right? So you got to kind of start thinking about that. Anyways, a cylinder, a cylindrical container with a height of 2 feet, has a diameter of 1 foot, is 3/4 full. So that's important to notice, right? I could have told you, you know, it's 60% full. What's 60%? 0.6, right? This is 3/4 full, that's 0.75. So how I would approach this, I would go volume of chocolate, right? How much volume do I have? I would say it's 3/4 of the volume of a cylinder. Okay, I'm going off script here a little bit, so I need to make sure I don't mess this up, right? I did make a mistake on the net diagram of the box for the bracelet. If you ever got there, is it a bracelet? I don't even know what it is right now. I made a mistake. You're right, it's 5 is the height of the box if you get there. 3/4, so 3/4 of pi radius squared h. So 3/4 of pi, the radius of this thing. Okay, do I have room for a picture? I think I can. Right, so this is the container, and we know it's only like 3/4 full. Okay, and so we know that this is 1 foot is the diameter, and the container, okay, the container has a height of 2 feet. That's a pretty big container. And it's only 3/4 full, so we need to first figure out the volume of the full cylinder and then multiply it by 3/4 to just figure out how much we actually have. Okay, so it's kind of like a twist there. So radius is 0.5. We square that, we multiply it by the height. There you have it. So that'd be 3/4 of 1.57 something, and that ends up being 1.178 ... cubic feet of chocolate available. Okay, so I will say this is available. So it's not my answer yet, it's just part of it. I don't know, you should start to foresee things like what's going to happen next. I'm going to figure out the volume of just one chocolate ball. Like how much volume do I need for one ball? What shape are you thinking of? Sphere. Okay, I could say, hey, we're making chocolate that are like hemisphere. They look like a hemisphere. Okay, that's half a sphere. Okay, got it. I have a formula for that. So just read carefully. But what are my units in when I look at the radius of the small chocolate ball? They're in inches, right? So when I figure out that volume, I'm going to be in inches and cubic inches. So what I'm going to do is I'm going to already turn this to cubic inches. Okay, I'm going to convert this volume. Mr. Dirksen, what if I just leave it like that and convert this to feet, and then just find the volume of the small sphere in feet, in cubic feet? Does that work? Yes, you can do that as well. You're just going to get a very, very small number You just have to be okay with that, okay? What's the trick to convert anything in inches to feet? Do you remember? Were you awake the first week? Anything in inches, I go over 12. And then you turn that into feet, okay? That's the quick way of doing it. So what I'm going to do is I'm going to take this, and I'm going to say that 1 foot has 12 inches, right? But a cubic foot has what? 1,728 cubic inches. Put this on your study sheet if you don't have it. I would do it right now, okay? What I did is I took 12 and then multiplied by itself 3 times. 12 times 12 times 12 gives you this. So I can cancel cubic feet, and I'm going to get, if I multiply this times that, I get 2,035 and 0.75 ... cubic inches. So now I have my volume in cubic inches. That's what I want. So this step is usually worth a mark, some sort of conversion at one point. Okay? Don't be scared of the weird units. It's just, right? We're just cubing it in this case. So now I'm going to go volume of a sphere. Okay, just the one chocolate ball. So that's 4 pi radius cubed. You don't have to always write out the whole formula. I do that for you. Most of the time it's just for you to have. If you plug this into your calculator, and some of you need to do homework, honestly, just to learn how to type this into your calculator even, right? Because some of you know how to do it, but you don't type it in correctly. Don't forget to divide by 3. That's the most common mistake that I see. So we've got how much volume we have in total. We have how much volume is one little ball. So when you're asked how many you can make, I just go like this. What does it ask for? How many? Okay? How many? I'm just going to go volume of the large container divided by the volume of just one. You want the units to be the same, or else this doesn't work. You get 90.68 something. How many we can't have decimals, okay? With these types of questions, you have to round. I'm going to say approximately 90. That's my final answer. Because I don't quite have enough for 91. But if you put down 91, the province, 99% of the time would honor that. That you can't have decimals, so you got to go 91 or 90. I would say 90 in this scenario because you don't have enough to make that extra batch, okay? Okay, so what I'm going to say is, I'm just going to check if I got that right. I'm going to say, please try this one for homework. At some point, I would say it's the same kind of scenario, the same kind of reasoning. And I want you to also try this one. And if you haven't done this yet, okay, if you haven't done this yet, change this 5 to a 4. Because my key uses 4 centimeters for some reason. It uses 4. I made a mistake, so let's just change that to 4, and that will save you a lot of grief. If you've done this and you use 5, you are right, okay? You are absolutely right. All right. We're gonna start doing the renovation type of question where we use what we've learned and apply it to word problems, okay? I would like to add one tip, which is found, I'm going to use page 27. Some of you use 27, maybe, to write down some notes. Just find a space on 27. I will say this. Surface area of walls when it comes to irregular when it comes to an irregular room. What do I mean by that? Okay. It just means when you have a room that looks like that, for example. Right? It has like a cutout. It's not a perfect rectangle. When you have one of those, you multiply it, you go surface area of walls. So I would have it on my study sheet, just go surface area of walls next to an irregular shape. Okay. If you just want to paint the walls, I'm going to ask you to figure out the perimeter. The perimeter, so the distance all around this, and you multiply it by the height of the walls. That's the tip of the day, okay? Because some students figure out the wall along this side of the room, and then this one, and this one, and this one, and they add it all up, and they make a mistake because there's so many steps that they had to do. The quickest way is to just add up the distance all around, and then multiply it by the height, and voila, you've got the surface area of the walls, okay? So that one is just somewhere on here. If you can add that to your study sheet, that would help you a lot, okay? It would go a long way. All right. You're good to go? You can move on. I'll come back to 27. I'll use up that space at some point. Okay, so let's go to 28. I'm going to get you started, and we're going to use the rest of these questions for homework, okay? It's important that you practice. So page 28 right now. A dome tent, okay? Just making sure I have this ready here. A dome tent in the picture has a diameter of 15 feet. So let's label this thing, okay? From here to here, we know it's 15. And it's shaped of a hemisphere. Okay, we know what that is. And the tent has no floor. Okay, that's also important too. I could change this question and say it also has a floor, because most tents do have a floor. I would not want to sleep in that tent because there'd be bugs all around you, okay? How many square yards of fabric are required for the tent if 5%, sorry guys, 5% extra, so that extra was supposed to go right next to the 5%, is needed for the overlapping parts? Okay, so I think most of you would know, okay, this is surface area, because we're talking fabric. You're covering something, you're not filling. Surface area would be 2 pi r squared. So let's figure that out. 2 pi 7.5 squared. So I'm starting a little easy so you guys can get used to it. So that would be 39.27, I believe. I'm just going to double check. Something doesn't look right on my key. 353. I'm looking at my answer and it doesn't make sense. Oh yeah, I know what's happening here. What's the 15 in feet? And what do I need my surface area in? Yards. So you have choice to make. Do I just convert this to yards right away, this 15? Or do I keep it and then just convert my area? I already wrote down this, so I'm going to just go with it. This is 353.42. I like how you all answered in unison. That's awesome. Square feet. I'm going to convert that. What's the conversion rate there? 1 squared yard has 9 square feet. Basically, I feel like I want to add this somewhere in the notes here. I'll just say that 1 yard has 3 feet. So if you square that, if you square this whole thing, you end up with 1 squared yard has 9 square feet. So in case you're wondering, where did that come from? That's how you derive it if you don't have it on your study sheet. You cancel the squared yards, so basically divide that by 9. You get 39.26 something squared yards. Are we done with the question? We still need to account for 5% extra for waste, right? Or for the overlapping parts. If you're making this, you're sewing it, you're overlapping, right? And so you gotta add extra. So we're gonna go 39.26 something squared yards, and we're gonna multiply that by 1.05. Why is that? That's also an aside here. It's kind of like adding taxes. You add 5% for GST. So if it's 100% that you have and you add 5% to it, that's 105%. Okay? And so that turns out to be 1.05 as a decimal. So when we multiply that by 1.05, you add 5% to that answer. So let's take our answer and just go times 1.05. So we need 41.23. That is my final answer. That's when you can round to 2 decimals. If you want to highlight, I'm going to highlight the 5%, and I'm going to highlight the 1.05 because some of you might be somewhat new to this. I don't know. If you added 15%, if you had to add 15%, what would we multiply by? 1.15, okay? Just like that. 12% tax, you go to a store, you want to buy a PS5, times 1.12, right? Multiply that by 1.12, you added 12% tax, that's how much you're going to have to give the cashier. Some of you probably just have a credit card, you don't even look, just like here. Don't use credit cards. They're really dangerous. Okay? You start spending money you don't have. We'll talk about that in finance. There are 12 curved poles, okay, that support the tent at the sides. They each go from the ground at the edge to the top at the center. How long is each pole? Okay, so if we can have a little bit of a side view here, just one pole goes from here to there, right? So you've got 12 of them going to the center like that. How long is each pole? How would you do that? I kind of drew this. I should have made it a bit smaller. Let me redo this. I make it a bit smaller because I want to complete that shape. Right now you're just focused on that. Okay, that's your tent. This is the floor. This is the pole. What shape are you should you be thinking of if you zoom out? You have a circle. This is what of a circle? If we figure out the circumference of the circle, this is just a quarter of that. Would that make sense? One pole is a quarter of the entire circle. So we know this part. We know that it is 15 feet. So the radius of this circle is 7.5 feet. We already determined that as well. So one pole, I'm just going to go pole. Pole is a quarter of the circumference. Do you remember circumference? It's been a while, right? What's the formula for circumference? It's pi times diameter or 2 pi r. So maybe that's something you want to add to your 2 pi r is the circumference. So a quarter, 2 pi, the radius is 7.5. So that's basically 15 times pi, right? 2 times 7.5 is 15 times pi. And then we take a quarter of that. I want to show the work though, because some of us rush and then forget. So times a quarter is basically just divided by 4. So it's 11.78 feet. This is what I'm after. So each pole to go from the bottom to the top of the tent. So you're for a minute just going 2D, okay, just going flat. Imagine this is right at the middle, and you're doing like you slice this up. You slice it up right there, and you put that sideways, and you imagine this. Okay, so that's how you do that. That's kind of like the idea that I want you to start thinking about. What time is it? It's too late to do more stuff. Okay, I'm going to ask you to try numbers 2 and 3. So basically pages 28 and 29. So I'm going to put homework here. Pages 28 and 29. Listen carefully. I know you're going to bust, you're going to have issues along the way. I know that. In fact, I almost expect you to have a little bit of that moment, okay? But you will only find out if you try it. If you don't try it, you'll come to class tomorrow and be like, Mr. Dirksen, that's so easy. I'm just going to copy this down. You make it look so easy, right? I don't want you to be like that because that's going to bite you, right? You want to come in tomorrow, you tried this, okay? And even if you're saying, you know what, I don't want to mess up my notes, do it on loose leaf. I don't care. Staple it later, and then leave this for me to fill in. Okay, but I am going to go over this. Look at the key, perhaps. It's very important for you to try.